Welcome to Command Shift Left, the podcast that helps you navigate the treacherous waters of the software development, ops, and security world while also diving into the hot current trends in the industry. Join myself, developer Philip, our co-host or Vice.
Hey audience!
As we battle through hilarious real-world stories, pro tips and hacks for navigating your way around developer security, learning about our Shift Left life, and life stories that have saved our ass.
We have an immense pleasure of having two incredible guests with us today. We have David and James. It's awesome to have you here. And let's start off with very short introductions. And in no particular order, let's start off with David.
Hi everyone, I'm David. I'm the founder of ArcJet, which is an SDK that helps developers build security functionality like bot detection, rate limiting, PII redaction, attack detection, build it into your application, just a couple of lines of code. And I also write the console.dev DevTools newsletter.
Amazing. It's great to have you here. And James?
Hello everyone, my name is James. James Jarvis seems to be the memorable part of this. I'm currently a senior software engineer at Thought Machine. We build these core banking platforms, and just before this podcast, I was running a bank the size of Barclays, just kind of testing it. So that was quite fun. I've worked across London, the Bay Area, Singapore, and I like to write about my experiences and what I do on the side. I like to, build stuff on the side. So that's me.
Well, James, it's nice to have you here as well. And I guess it's the perfect time to start off and kick off with our first fact. And I believe that fact belongs to you, Or. So why don't you take it away?
Thanks, Philip. How come it's always my fact first?
It's just the way it is.
So my fact for this episode is that with everything as code growing, programming is becoming more and more meta. So first of all, maybe we should cover what the hell is everything is code. So everything is code is a trend in which we basically as humanity, we've agreed that complex things are best represented as code. So if before we'd use like charts and we'd use different markup languages and we'd use just data to represent a lot of our complex information, we're seeing that especially with things that apply, change, or interact with one another, or require a specific layout, configuring it or setting it as code and managing it with all the best practices of code, aka using source control and applying software development life cycles, we see that is the best we can do with managing complex things. And this has started with things like infrastructure as code, with things like Terraform and Lumi and other utilities kind of growing with the cloud and with microservices. It continued with things like configuration as code. So nowadays we less and less represent the configuration of our applications as just data, but we have actual code files that represent how we expect the application to be configured. And also a common example is policy as code, meaning how we want our compliance, how we want our authorization, how we want our interaction between allowed interaction between components to be enforced is also done by code. And all of this is great. These are becoming very prominent tools that are used across the space. But there's another interesting phenomenon on top that is starting to arise. This thing is growing, and that we are starting to use these tools on these tools. So, and when you think about it, it kind of makes sense because your policy is code. So now you want to manage it with code. So one of the best ways to make sure that code behaves the way that you want is that you have a policy for the code. So now you have policy as code for policy as code. And you have policy as code for your configuration as code. And you have configuration as code for infrastructure as code. And you can now, I dread to say it, but you can have multiple recursive layers. So you can have policy as code for your configuration as code for your infrastructure as code for your policies. I can confess that in Permit, for example, we do infrastructure as code to generate policy as code. So we have a Terraform provider that generates OPA, Rego code for you. And now we're adding policy as code. So we generate policy as code, but you can also define a policy that will guard how your policy as code behaves. And I believe we're just scratching the surface here, especially with AI coming to the field. And now AI is generating code for us. So now we need policies to enforce what the AI will be doing. I'm expecting this to cascade ad infinitum and probably ad nauseum very quickly.
I was picking up on that because there's this famous quote where like the final language that will ever be written, everything will converge eventually to English, and suddenly like all your code, all your policies, everything will just be kind of an English sentence, which then almost goes full circle with what the first contract was. That was like the legal representation that was originally in English, different language, but sure. So I suppose it's like confession. Have you ever gone into a Gen AI prompt, written what you want to do in English, had that generate Terraform, which generates OPA, which generates code? How far have we gone so far?
So I've done so, but nothing the like direct sequence. So I did use ChatGPT to generate Terraform code that I used as a template, edited it, and then I'd use that to run with Permit and generate policies code. I haven't done it like in full sequence, but I guess it's just a step away.
Nice.
And I didn't even think about it now that you mention it.
Where does it all start? That's always the challenge with Terraform, right? So how do you actually bootstrap the initial environment? Because the Terraform state has to be somewhere. It's usually local to begin with, and then you have to put it somewhere so that you can share it, but it still has to be locked, and getting that initial inception point that's the most challenging bit, that initial bootstrapping of the environment. Once it's up and running, that's great.
Yeah, but the solution is, of course, clear. You have configuration as code that sets up your initial configuration for your Terraform, and of course you have policy as code that enforces that configuration. And of course I'll stop here.
Everyone listening, their ears are just going to hurt. Too much recursion in one go.
So far, I think we've only done 4 levels, so this can get much worse.
4 levels is enough.
Plenty more room for improvement.
I wonder if you have like cases where you think that this would be like, it's easy to see how this gets messy, but are there cases where you actually think this would be good? This should be the thing that we do.
Actually, how do you control this not getting messy? Like, you have to have very clear outlines of how things are managed, I guess.
There's actually a very easy answer there, and the answer is abstraction and encapsulation. So, like, think about it when you're writing code today, like you're writing, I don't know, let's say you write in JavaScript. So, and JavaScript is actually a extra horrible example. So you write, let's say, TypeScript or even regular JavaScript, and that gets transpiled into the actual JavaScript that's going to run on the interpreter into a virtual machine. And that virtual machine is being built and is written in C, C++, maybe Go nowadays, or Rust. And that gets compiled into machine code, and that machine code, so actually you have virtual code that runs on the interpreter, and you have the machine code that actually runs for like the browser or the V8 engine on the actual CPU. And there's also abstraction layers there. And of course, that machine might be like a VMware, like another virtual machine, another physical machine. So there's another interpolation layer between what's actually running on the CPU, like if you have a hypervisor on your computer. So there's a lot of this recursive mess already happening, and you're not aware of it because we've wrapped it in nice encapsulation layers for you. So potentially, you can also imagine abstraction and encapsulation also coming in here, but it hasn't quite happened yet.
Yeah, I suppose going back to your kind of first point of like, why is everything becoming like everything as code? There's sort of 2 parts to that. There's 2 bits of value. There's the abstractions of, like, as you were saying, like, I mean, it's useful for JavaScript because JavaScript is a terrible language that lets you then get to a useful language like assembly. And so that has a bit of value. There's a lot of complexity. You need to abstract away. You don't want to have like different compilers or different architectures. So that is clearly an abstraction use case. But then for like infrastructure as code, policy as code, that's kind of like a config. And I feel like the value they're getting isn't necessarily the code part. It's more the everything else around the software development lifecycle, the Git, the ability to basically manage a text file and have that generate something else, which is quite useful for everything else. I feel like that's primarily the value there. It's just config. It's more just everything as configuration, and configuration being shareable.
The thing is that, first of all, you're totally right. Like the best practices of managing code are a primary thing here. But it's not just that. It's also the ability to express complexity. So the ability to have loops, the ability to have templating, the ability to have recursion in building, or the ability to have something like object-oriented in what you're representing, or declarative objects. Those are also very useful across this entire space. And I can tell you, for example, in policies code, you have things like relationship-based access control, where you build a graph and you navigate on the graph to deduce if someone has access to something or not. So it's also about the complexity of the runtime, like what you can do with the language itself to express complex patterns. And it's a combination of the complex patterns and how, as teams, as society, let's say, we go about working on them together without losing which side is up.
Infrastructure as code seems like the odd one out here, because it's the one that is describing what you want something to be, not necessarily what it is. Whereas code, like pure code, is executed at runtime, so it is what it is. That's what happens. And most of the time, you want infrastructure as code. It does match infrastructure, but then you get drift, you get errors, and it's kind of evaluated at a very different point in the life cycle, which is also why it's often the most frustrating of the categories, because it doesn't always work in the way that you think it should do. It can be complicated to kind of wrangle it into the right way, whereas code is code and it just does what you write.
Though you do have the challenge with code of how deterministic it is, like how clear it is to debug it, essentially, how easy for you to say is, oh, this is how the code is going to behave. And obviously there's the halting problem, like you look at code, you can always map out all the scenarios that the code can end up at. And obviously the solution for that is to have additional code that will check if that code behaves. I'll stop here again. And I actually think this is not just a good point to stop with the recursion, but also a terrific point to move on to our next fact.
And that fact is by you, David. So why don't you take it away?
So my fact is somewhat linked because Amazon describes a number of anti-patterns for everything as code. And the first one on their list is checking in secrets. And my fact is similar to that in that environment variables shouldn't be used to store secrets. I think that is an anti-pattern. And it originally came from this idea of the multi-factor application, which has been around for a while. And it seems like a natural place to put a secret, because where do you need to access it? It's available in the environment that your code is running in. But as soon as you interrogate the idea in a little more detail, you realize how awful an idea this is, because an environment variable is just a string sitting in memory with no ability to version it, no ability to audit when it's being accessed, and an infinite ability to exfiltrate it in any way you can possibly think of. You just load up a terminal on your computer now and type env, and you'll see all the environment variables you've got configured. Maybe you've got some tokens in there that could allow you to access your AWS account. Maybe you've got some database URLs that allow you to log into a, hopefully not production, maybe your local instance of your database. But the same thing happens on servers and in production. So all you need is a remote code execution vulnerability, and you can very easily exfiltrate all of the secret values from your production environment. And so I think the solution to this is to be reading in the secrets at runtime on demand when you need them, using some kind of secrets management tool, whether it's a commercial product or an open source product or something provided by one of the cloud providers, something that isn't using environment variables.
Wait, but how do you get the secret for connecting to the secret management utility?
That is the only secret that you have available, because you've got it. Going back to the inception problem of infrastructure as code, you've got to start somewhere. But having that token available is what gives you access to your secrets management tool, and all the access can be logged, can be audited. You can version it, you can revoke that token, you can have it session based, so it's issued on every restart or every deploy, or have it different for every environment. And unlike a variable that's just sitting indefinitely in memory forever, this token can be much more ephemeral and controllable.
Wouldn't that still remain kind of a vulnerability, but just with extra added steps for the person who wants to, bypass the security and get access to the tokens?
Yep, absolutely. There's no 100% secure way of doing this, but there are bad ways and good ways. Like, you've got to have secrets somewhere. They've got to be in some system. It's just how easy is that system to access? What controls do you have on top of it? Do you know what's going on? That's kind of the key question when you're doing any kind of forensics or vulnerability analysis, is what was accessed and by who and when. And if you just have your secrets in memory, you have no way to answer any of those questions.
This reminds me of a very similar dilemma, which is also debated a lot, which is where do you store tokens in the browser? You should do it under the cookie storage, or if you should do it in pass it as headers, or use local storage. Essentially, cookie and headers are the same thing, but there's the local storage option. And every time I check on that question, the default answer, or the primary answer, switches because there's pros and cons for both. And I think here maybe also there's pros and cons to managing things with environment variables, or managing things with a secret management tool. And I wonder if there's a sweet spot, a balance point between the two. Have some things as environment variables, have some things as in the secrets management.
I guess in some way, the more complex, in some way, you make the management of environment variables, the more complex it gets for someone to infiltrate them, or it exponentially grows, no? You can be clear as the engineer, developer, of the steps you need to undertake to get access to them. But for someone who doesn't know, that kind of exponentially increases the difficulty of infiltrating them, right?
The values are in memory at some point, but it's much harder to access memory than it is to access an environment variable just through a remote code execution vulnerability. So that's the distinction, really. And I think also the distinction is not never use environment variables, but don't store secrets in environment variables.
There's a question here from security theory. One of the key points in security theory is that every guard component you put into a system puts on pressure both on the users and the attackers of the system. And one of the key principles is if you put too much pressure on the users of the system, you'll end up having more vulnerabilities, because then you'll have your users do more mistakes because it's more complex for them, or they'll try to bypass the security mechanisms, and you'll create more friction than protection. So I really think it's really about it's a balancing act. But I firmly believe in what you said, David. First of all, there's the clear cut between, is this a secret or is this just a configuration that I'm passing in on the environment variable? And also with the meta concept here, the secret for the secrets. Maybe there's some meta secrets that you can manage in environment variables without breaking everything apart. But I guess it's also a case-by-case question that an engineer needs to answer.
The secrets for the secrets for the secrets for the secrets. Recursion again.
Yeah, it's kind of like also who watches the watchers.
Yeah.
James, what's your take?
I've been trying to think about this. I'm not sure there's a good answer for it. From all my experiences, there's been a mix of both. People seem to use environment variables sometimes because partly what makes them so vulnerable makes them nice and easy to use. So if you have like container-based deployments, you have basically only environment variables accessible to that container, in which case the container should be so small that even though it's visible to everything inside the container, that's kind of fine. And the idea is that you shouldn't be able to access that container, because then if you can do that, like you're screwed anyway. You can see everything. So then how do you access control to that? And then you have to I don't think there is a good solution to it. I think Philip's point of just basically security through obscurity, as good as we can get. And then again, what you said, David, just being able to quickly revoke like available tokens, making sure there's a centralized place to control like the life cycle of those tokens. That's probably as good as you can get. Something that can then basically provision tokens on restart, like session based, as you said, push them to where they need to be, and then have somewhere else where if you've seen unauthorized access using one token, you can just revoke it. That should kill the deployment. I mean, that's probably it. I'm not sure about the environment variable versus like passing into arguments.
I think it's about having a good developer experience to encourage developers to make the right choice. And that typically means having an SDK that they can use natively in their whatever language they prefer. You can give them type hints, and you can get the documentation in your editor. You can have a local copy that is the same as running in production. But really, this is about adding layers. Like you said, if you get into the container, then you've got a big problem. But it's not necessarily just getting into the container. You can have a remote code execution vulnerability in your code, in your runtime, in your operating system. And so the question then is, well, when that exists, because they do exist, what is the next layer that's making things a little more difficult? And the goal is never to get into the container. There's nothing interesting in the container. It's what the container is connected to and has access to. It's kind of that lateral movement piece. And really, you want access to the database. So you want to get the database credentials, a URL to be able to connect in.
Another aspect that I like about this, like there's this dimension of basically penetration and lateral movement within the attack surface. But there's another dimension here, which is the auditing dimension. So even if we don't block, even if we don't make it harder for the attacker to move forward, the fact that we have more information on what is being interacted with by which identity potentially and when gives us a lot more color as we're doing incident management. And if you connect this like behavioral analytics and other classic security tools, even if you're failing in blocking the attacker, but you now have more alerts, you have the ability to recognize these attacks better. Even just that is very valuable. But of course, that requires more orchestration around this thing, just the secret management. It's connecting it to your security apparatus.
Hopefully not more alerts. No one wants more alerts. you want some kind of anomaly detection, I suppose. If whatever the environment is suddenly accesses a load of new things that it didn't previously access, that's when you want the alert, not necessarily the secrets are being accessed.
Definitely agree. Cool. So I think this preps us to move to our third fact, and that fact belongs to Philip, take it away.
All right, so I am quite excited about this one because this conversation has diverged into the right direction to present my fact. And considering we have David, who obviously is the founder of ArcJet, which is a security company for developers, and James works in banking, I'd be interested to hear your guys' opinion on this. But my fact for this episode is that hacking or accessing vulnerable data might become impossible in the future if we start to implement the magic of quantum cryptography. Now, let me elaborate on what quantum cryptography is, because it's quite cool. So essentially, it's a quantum cryptography is something that uses quantum key distribution, or in short, it's called a QKD, which sounds very technical, but it's actually very, very cool. Now, the key to this whole thing is the quirky behavior of how quantum particles actually act. And they're like photons, so they're like particles of light. Now, the cool thing about this is that these particles can exist in multiple states at once. So here's where it gets interesting. When you're, for example, sending a message or sending some data by using quantum key distribution, you're not just sending, ones and zeros like we usually do in normal encryption, but we're sending photons in different quantum states. Now, because of a phenomenon which is called quantum superposition, let's assume if a hacker tries to intercept these particles or this specific, security that we have going on, the very act of observing the very act of just observing the changes or accessing that data changes the state of those particles. Now, this is called the observer effect. So once someone kind of peaks, then the message is altered, and the sender or like the legitimate sender of who is sending that message and the receiver, they kind of instantly know that something fishy is up. So essentially, at that moment in time, the hack attempt literally destroys the message before the hacker can get anything valuable out of it. Now, since kind of a message like this is detected, the system just stops the communication and essentially leaves the hacker empty-handed, and the message is safe. So this kind of technology, the quantum superposition, the observer effect, and just the idea of using quantum key distribution is already used in banks and governments, to protect the most sensitive data. So I'm interested to know David's and James's opinion, considering they are in this space. And also, I guess, we're both in security. So I guess it makes sense just to ask the question to everyone. But yeah, what do you guys think about that? Do you think hacking will or could potentially stop?
I'll go first. I know nothing about this. I just got ChatGPT to give me a great little summary right now. And I immediately have a kind of a question about it. It sounds like the benefit of this is that you can, because if you send information and it's quantum entangled or somehow locked together, as you send a copy of it, it should somehow be connected, so that as soon as it's observed, the state for both should change at the same time. Now, if you're sending information from A to B, as to Bob or something, surely the B needs to know they've received the correct information, and A needs to know that B's received it before it kills it. So wouldn't B need to tell A that it has observed the information to know the information has been received? If so, then a man-in-the-middle attack, I mean, if it's that simple, I doubt it's that simple, then a man-in-the-middle attack could just observe it and respond back, we've seen it. I'm sure there's a way around it.
That's called a replay attack. That's something you can do today, and there's also mechanisms to protect against that. You have an additional token that is sent you, like you do a two-way exchange, so a replay attack can't come into play, because if you just send that message, you don't have the most recent bit that needs to come in next in the conversation, and then it is known that you're a man in the middle and not the actual party conversing. And so I'm guessing you'll be able to do the same thing with quantum conversation. I think probably easier, probably like part of the quantum information, something that is coupled to something that the other party already has, and only it can collapse the wave function in a way that is expected by party A. But I think there's a bigger hole in the plot here than like the physics and the security aspects. I think it's just fundamental reality. And this makes me think of a classic XKCD, where it's describing security in regards to a $5 wrench. So it goes what do you imagine? Okay, I'll have all of these encryption mechanisms and they'll try to break it and they won't be able to, and they'll just get stuck and they'll give up. What actually happens is take this $5 wrench, hit him on his head as many times as you need until he gives you the password. So you can build all these complex mechanisms, but in the end of the day, a lot of classic technologies like a $5 wrench can throw a wrench in your plans. So there's always the human factor. There's always bugs that you'll have in software, be it crypto software, be it quantum software, be it whatever software. There are always going to be some types of vulnerabilities. They just change. So yeah, I don't think hacking is going away anytime soon, or probably never, ever.
Yeah, I think the human component is the area of the most risk. If we go back to encryption today, PGP, you have a private key and a public key. And the classic flaw there is people accidentally send their private key and they publish it on the internet rather than using their public key. And if you've ever tried to send a message using PGP and email, it's very difficult to get it right. And then someone just replies in plain text and they include the full email chain as part of the reply. So I think it's less to do with the technology, which sounds really cool and interesting. And if we can get that working, that sounds promising, but it always comes down to the user interface. And for developers, the developer experience, how easy is it to implement it, and how easy is it for the user to actually use it? And it sounds like it might not be that trivial.
Yeah, I know that the current technologies, or the current state of the art of encryption, is basically just to try as many as you want. You just keep wrapping your little packets with as many layers of encryption. So just pick 5 of your favorite encryption algorithms and just wrap it 5 times. And they're like, even if you break one of them, the rest of them will protect you.
That's a bad idea.
We're still getting hacks. So
yeah, when you do something like that, so one of the key aspects in cryptography is deducing the encrypted content by recognizing patterns. So by building encryption algorithms one on top of the other, you're basically increasing the odds that some patterns will emerge in the final cipher, and that will actually give the attacker more information and more opportunities to decipher. Encryption really needs to be used in a very precise mathematical way, as to not create more mathematical patterns that you don't necessarily expect or want.
Interesting. Wait, so if you were to wrap with completely different algorithms, it becomes more easy to find a pattern.
We're getting more patterns. So by the fact that you've decided, so you have your original information that already has patterns because it's information. But unless I know what that information is, I have less information on what you're trying to do. But if you are encrypting something that is encrypted, there's a clear pattern here that is easier to see because it's on everything. So you've increased the likelihood that I'll be able to understand the nature of the information. And that will enable me, that additional information can allow me to have more techniques to decrypt what you've encrypted.
So the less is more, basically.
No, it's like you need to use tools the right way. Like if you're going to eat soup with a fork, you're going to have a bad time.
Right.
So technically you can do it. Yeah, you can go and eat soup with a fork, and a lot of times you'll be okay. You'll finish eating your soup and things will be all right. But sometimes you'll poke yourself in the eye or something.
One of these days I need to read up about all these forks that transport my packets somewhere.
I highly recommend doing so. It's, I think, the duty of every engineer working on software. And James, as you've raised some interesting points here, how about you also raise an interesting fact?
So I have a deliberately boring fact. It's an extremely exciting one, actually. And I was trying to think, over all the years, what fact has kind of maintained or kind of been persistent the whole time? And it turns out that boring is best. So, and I'll elaborate on this. So imagine you're building something. You're really excited. It's a really cool idea. You want to build Uber for penguins or something. As you're building Uber for penguins, you're going there and you're like, I need to build a whole new front-end framework. To build a front-end framework, I need to build a build system. To build the build system, I need to build a cache, I need to build S3 again. And you basically end up like yak shaving your way to oblivion. And there's this kind of concept called it's like innovation tokens. The idea is that when you start out a project, you'll have like a few. And each one is so kind of emotionally draining or resource draining for you to actually complete. You want to keep those focused. You want to withhold them as much as possible until you get to the task you want to actually accomplish. So don't go down, building new build systems or writing your own databases. You want to just keep it for your Uber for penguins. And so we've kind of seen this play out a few times. Previous companies, they would start out, the latest, the hottest thing they've heard about on the internet is just building this project, going around with CoolDB version 2 or something. And they end up wasting loads of engineering time. They're just going back to, we should have just used MySQL or something, Postgres. And that's if I could share any nugget of information with any engineer, it would be that. Try what you know.
Sounds like a common plot for perma.io. Engineers trying to build authorization and realizing that they probably shouldn't have built it from scratch.
Yeah, exactly. You can build your own like permissions-based authorization in memory if you really want to, but then suddenly you need to shard your application, and how do you share the state between them? Yeah, it's getting a bit complicated at that point.
So this concept of undifferentiated heavy lifting, right? That's what the CTO of Amazon famously said many years ago, describing what AWS is doing. So things that as a company, you don't need to reinvent whatever it is. Most of your time should be spent on your product and adding value to your users, not building authorization, authentication, some custom database, at least not at the beginning. Like when you're at Amazon scale, there's a different question. But even they used Oracle database until the last couple of years. Amazon itself was running on Oracle. They had this big project to move off it and onto AWS's products. But they're at such crazy scale where it makes sense. Whereas everyone wants to be Google or Amazon, really you should just get something off the shelf from the cloud provider, a product from a SaaS provider that can solve all those things, and just have all your engineering time going into building user features.
Exactly. I guess a follow-up question to that is, has there ever been a time where you've like just run away? You've forgotten that we're actually building this thing, and you run away and you're building the thing that builds the thing instead. Got any fun stories there?
There's a lot of times where I found myself forking things into like a new idea or a company, but I'm kind of an odd bird in that sense. I actually go about founding companies. I don't recommend this, by the way. It's very taxing and takes a lot of time and energy. But I think I do try, like when it comes to developing products themselves, I try to not reinvent the wheel, and I constantly ask myself, what is our core business? And if something is not part of the core business, I really shouldn't be building it. And in Permit, like a lot of times we had things around authentication or around SAML or identity management. There is that edge of, okay, maybe we should do that as well. But no, it's about having focus, having clarity, having the ability to say, these are the things that I'm going to do, and these are the things that I'm not going to do. And there's so much things that need to get done, unless you have that logic, you end up not doing anything. You'll just be starting new projects constantly and never finishing them. And I actually think that's maybe a problem that's a problem that a lot of engineers express that they have. So maybe it's connected to that.
Yeah, I was going to say, I think every engineer who at least tries to build something on their own end to end, I think falls into this loophole of deciding, okay, I'm going to use this and this to build this, this stack and this database or whatever. And then suddenly they come up with these features and they're like, well, I could use this, but then I could also build this myself. And then every engineer at some point thinks it's a great idea to build it themselves. So they go for it, and they very quickly realize how much of an ache that is to do. And I think every single person kind of goes through that stage at some point when they're developing something, and hopefully learns their lesson. I guess some don't, but we would hope that they would do, just because it's very tedious. And realistically, always the idea that comes out of this is, why would I want to build this myself? And put myself or put the code I'm writing at so many risks of vulnerabilities or misfunctionality, where there is probably a dedicated team, a whole company that does this, and they dedicate all their engineers and everyone who is a professional at what they're building to exactly understand the topic and to solve it. So at one point, you'd hope that most engineers, when they're coming up with a startup or coming up with an idea of building something new, they focus just purely, like you said, David, just purely on the value of what they're building, and to always take that further, and then utilize as much resources on the side that are already built by others who know exactly what they're doing. And I think that's what kind of makes it, or makes some other companies with new, fresh ideas successful, because then they just dedicate their engineering time on the things that are important.
The problem is it's fun, right? That's
yes.
That's why we do it. So I try and do this just on side projects, like play around with stuff just on side projects. But everyone's done the side project that they build and then they put aside, and they come back to it 9 months later and they have no idea how any of it works. And that is the problem with doing the same thing with a real business, in a real project, is you've built it once, might do the job today, but then in 6 months' time, when you hit scaling issues, or you need to add a feature, or the person who's built it has actually just left, then that's where you have the problem.
Yeah, I actually recall one situation where I did this myself. I was going to just build this e-commerce site, but I wanted to make it really fancy and creative with the UI. So I was like, okay, for the payment method, I'm going to use Stripe, but I'm going to design the card myself and animate it. And I'm going to make sure that every field I enter is animated and the user has this amazing user experience, where there's already, companies that do this. You can just import this UI widget and it just works. But I was like, yeah, I'm going to build this on my own. Very fun, horrible. On the other hand, horrible. It just took way too much time. Those constant bugs, those things that I never thought of beforehand. You only realize after you do it. So yes, but yes, the fun aspect is definitely there for sure.
And a credit card interface is not where you want bugs. You want that to work.
Yes.
We've joked so many times at work. So many people have raised this point. Where we've had issues with existing database providers. We're like, do you know what? How hard can it be? Let's just make our own database. There's some poor sod in the back of the room, twitching as if they just had a seizure or something. Don't do it. Don't make your own database. It's a terrible idea. I'm sure one day we'll listen to them.
I think this problem, I put it in quotation marks, I think is to some degree getting more difficult or more tactical. Because if in the past we had to choose software in bundles, like applications, libraries, now as engineers we also have this dilemma with even lines of code. Because we can, for every line of code that we want to implement, we can go to our AI and ask it to write this line of code. And I think, first of all, it's becoming apparent that the concept of what we see as an engineer is changing dramatically before our eyes. And I think this is another dilemma. As a good engineer in a year from now will need to quickly answer what are the lines of code that I actually need to write myself, and what are the lines that I'm going to delegate to an AI, and what are the lines that I'm going to consume as a package, and what are the lines that I'm going to consume as a product and as a service, etc. And I think maybe that's starting to become one of the more critical points of differentiating between a good engineer and just a okay engineer.
There's another concern though, as AI has come around and it's becoming easier for anyone to write code, like quickly. You can even like have it generate tests. Double check them, please, first, but you can have it do that. And there's this fear that the barrier to entry of doing these side quests is going down. So what if you had?
Why is there a fear? Why are you fearing that?
Well, what if? So, as David said, you do kind of accrue this tech debt. If you have a finite organization, but you have increasingly like infinite sort of growth of code, you can have a case where your tech debt can turn to like tech delinquency. You can kind of default on your tech debt and start to pull you back. So there's a warning in there somewhere.
So that's very interesting. I actually think this is a conversation for like an entire podcast, but maybe just try and touch on it quickly. I think there's a difference here between how much expertise you need to be able to write the code and the expertise you need to be able to make the decisions on who or what is writing the code. So the level, like if in like 10 years ago, you needed more expertise of being able to fashion the software yourself, now that is becoming less critical, but the ability to make decision-making on how you cobble it together is becoming more critical. So, and this is a new layout of skill set that an engineer would need. So some people that before couldn't be engineers because they didn't have that bottom line technical capacity can now become engineers. And some engineers that had a lot of this technical capacity but don't have that decision-making capacity will become, less qualified to be engineers. So there will be a new type of engineer that is emerging, I guess. And that is kind of frightening, but I think all in all, we'll have more people that will be able to author software, and I think that's a good thing. I hope,
because we're all so confident in the software that we're already writing.
Maybe the more people, more eyes on it, maybe that will give us the confidence finally. Before, and of course, obviously, in the end, Skynet will take over everything. That will give us the confidence that we need to do what it says exactly. Otherwise, there will be penalties.
Yeah, I think in the future, there's going to be two skills required of an engineer. One is to actually write the code. The other one is to audit the code. Because I assume at some point AI is going to be writing like half of it, and you're going to have engineers just sitting there, just being able to understand what's happening and being able to confirm that what's happening is correct. And those are two different, completely, I guess in some way, two different skills that an engineer will have to have.
I like the term auditing because it also implies the risk management aspect.
Right. Yeah.
You look at a piece of code that an AI wrote. It's not just saying, will this work or not? It's how easy is this going to be to maintain? How likely is this to create problems? What is the security profile of this thing? How likely is this to work with some of the other code that we created? So it really aligns with the term audit very well. Cool. So maybe we're becoming software auditors, not programmers.
I think there is a distinct value there in that when something goes wrong, who do you call?
The Ghostbusters.
Will you? Ghostbusters. The bug busters.
Code busters.
I think I'll call you James. That's gonna be my default there.
I don't know. I think I make more bugs than I fix. That's my niche.
But maybe you audited them in a good way?
Maybe.
So with that food for thought, I think we'll wrap up this episode. David, James, thank you so much for joining us and for sharing these awesome facts with us.
Thank you very much to everyone listening, also watching at some point maybe. And we'll see you in the next one.
Bye, everyone.
I think this is the perfect time to wrap up the show. If you liked this podcast, tell your friends about it. If you didn't like it, tell your enemies about it.